This is a Pencast on acid-base indicators. An acid or base indicator is usually a weak, organic acid that will change colors after it loses an acid, loses a proton or gains a proton. So you might have some sort of organic compound, something like that, something weird, and then this would be, say, red, and then if you add an acid, you'll create some other weird thing with a positive charge because you're adding an acid, so it's a conjugate base or acid, depending on how you're doing it. So those acid-base indicators were discovered by the Germans. Of course, anything German, 1850s to 1900s. They were the organic chemists of the world back then, the Germans. And what they were doing is they were coming up with some dyes, some things that change color to color wool or clothing, yarn, and come up with different things. And what they found out was that if you, some of these dyes, organic dyes, would change color and turn into some of it over here that changes color might turn into blue. So if it's protonated, it's blue. If it does not have a proton, it's red. So they're the ones that came up with this, and there are literally hundreds of different indicators. Phenolphthalein is one, methyl red, methyl blue, there's lots of different ones available. They do change color within a range of 2 pH, which is 100 times stronger acid or base depending on which way you're going. So it's not a instant change off, it's a gradual getting darker and darker and darker, less red, and then change over to more blue. So there's a range of colors there. This is important because what pH, what indicator you want to choose depends upon where your equivalence point is. If you have a strong acid, strong base combination, suppose you're adding a strong base, and you have two different indicators, one changes in this range, call that A, another changes in this range, call it B. If it's strong, you can use pretty much any indicator. Now it looks like it takes a while to go from one to another, but it's really one or two drops will make it go from one side, from here to here. That's only one or two drops of acid or base, in this case base. So that's why when we do the pH things, it will be clear, and then you add one or two drops, and boom, it turns its color, like pink. That's the phenolphthalein color that we did in our last lab. So if you have a strong combo, you have a large variety of things you can use. If you have a same situation, a weak, strong base, A still changes within that range, but now B changes in here. You do not want your indicator to change in the buffered solution because it'll stay, gradually get change color. It won't be one or two drops like here. It might be 40 to 50 milliliters. So it takes a long time to do that. So you do have to make sure you know the choice of indicator And there's a wide range of things. There's usually a thing in the book about it, indicator. So the choice indicator really depends upon whether you have strong acid, strong base combination, or if you have a weak acid or weak base, where the equivalence point is. If it's in this situation, you would want something that will change color in the basic range. If you have this situation here, B would be your solution and not A for the same choice. So you just have to make sure you choose that. And like I said, the pH changes within a range of 2 pH. They came from Germans trying to find dyes for clothing, and they came from weak organic acids, and they're the ones that change colors. That ends this lesson on organic, on acid-base indicators.